Page 9, derivatives of trigonometric functions. Okay, so from the investigation or from the book, recall that the derivative of sine is cosine, and the derivative of cosine is negative sine. The derivative of tangent. Let's derive the derivative of tangent. Let's use the quotient rule. Remember that the quotient rule says that the derivative of the quotient is equal to, and the quotient being u divided by v, is equal to u dashed v minus u v dashed divided by v squared. So here's u, here's v. U dashed would be cosine. V dashed would be negative sine of x. Okay. Now let's use the quotient rule to figure out what would be the derivative of tangent. Okay, so we do know that it is u dashed v, which is cosine of x, times cosine of x, minus u, which is sine of x, v dashed, which is minus sine of x, divided by v, which is cosine of x squared. That is the derivative of the tangent function. So let's simplify. We have cosine squared x plus sine squared x divided by cosine squared x. So we could write it as 1 over cosine squared x, or we could also write it as 1 plus tangent squared x, for example. There are different ways to write it. Actually, 1 over cosine is equal to the secant, so it could be secant squared x also. Alright. Use the chain rule to find the derivative for these functions. So, the derivative of sine is cosine, but if you have a complicated function in there instead of just x, then you need to use the chain rule and you take the derivative of the inside function and multiply it times afterwards. For cosine, first you take the derivative of cosine, you get negative sine of f of x, and then you take the derivative of the inside function f dashed x. Tangent, remember that it is equal to 1 over cosine squared x. Okay, and then you multiply it times the inside function, which is f dashed of x. Okay. Okay, after you look at example 13, you'll be able to do these. Find the derivatives for these trigonometric functions. We're going to have to use the chain rule because what's inside here is not just x, but it's kind of a complicated function. It's another function that needs to be taken the derivative of. So, when you take the derivative of sine x, you get cosine, and you leave the same function inside, and then you take the derivative of what's inside using the chain rule. So the derivative of 2x is 2. Let's see, c. So first we're going to take this derivative and then we subtract this derivative. Okay? So the cosine of 3x, the derivative is negative sine of 3x, and then we multiply times 3. And the derivative of sine x is simply cosine of x. About e. The derivative of cosine is negative sine, and then you just write the inside function as is. And then you take the derivative of the inside function, you get negative 2. G. Let's see, the derivative of sine of x over 2 is cosine x over 2. And we multiply times the derivative of the inside function, 1/2. The derivative of cosine is negative sine x, so we could make it a positive 3 sine x. The derivative of 4 sine x would just be 4 cosine x. The derivative of cosine 2x would be negative sine 2x, negative sine 2x, and then you multiply times the derivative of the inside function 2x, which is 2. Now, whenever I write the 2 in the back here, I'm just doing it because the chain rule kind of happens afterwards, but remember that in algebra, the best way to write your answer is to put the coefficient in front. It makes it clear that you're multiplying it times. And like here, you can't really tell if I'm multiplying it, if it's part of the sign input. So you always want to put the coefficient up here for a test. Okay? Last one, sine of x divided by x. So this, we could use this using the product rule, or we could do it using the quotient rule. If we're going to do it with the product rule, then we could say that, okay, sine of x divided by x is the same thing as sine of x times x to the negative 1. And then we would say, okay, u is equal to sine of x. U dashed is equal to cosine of x. V is equal to x to the negative 1. V dashed is equal to x. Negative x to the negative 2. And then we're going to just do u times v dashed, which is x to the negative 1, plus u dashed, cosine of x, times v, which is x to the negative 1. And then, oh wait, where's our v dashed? Oh, it should have been here, right? Negative x to the negative 2. This was u times v dashed plus u dashed times v. Is that right? So negative sine of x divided by x squared plus cosine of x divided by x. Okay? And that's it for page 9.